Now we come to the next format where a plus b is given as 60 degree. Now whenever a plus b is given as 60 degree, then from here we get two standard results. First of all, sine square a plus sine square b plus sine a sine b equal to 3 by 4. And the second one which we have is cos square a plus cos square b minus cos a cos b equal to 3 by 4. With this, we keep another formula in mind where we have a minus b equal to 60 degree, and then we have two standard results. One is sine square a plus sine square b minus sine a sine b equal to 3 by 4. And with this we have another form, cos square a plus cos square b minus cos a cos b equal to 3 by 4. You can understand either a plus b is 60 or a minus b is 60. In both the case, the result for cos is same. But for sine, it changes. When plus, here also you have plus. When minus, here also it is minus. So this is how we can keep in mind. Let us take a sum here. We understand here that here it is given k equal to cos square 80 plus cos square 20 degree plus minus cos 80 degree cos 20 degree. And we have to find the value of k. Now here we can understand that here the angle which are given to us, if we can take this angle and this angle as some a and b, then we can understand that a minus b equal to 60. And when a minus b is 60 degree, then we have cos square a plus cos square b minus cos a cos b equal to 3 by 4. So automatically here the k will be equal to 3 by 4. So just this form will allow us to get the result very quickly. Even we can understand the logic behind this. It's a very simple expression. A minus b equal to 60. So we can just take here a equal to 60 plus b. Now we take cos on both sides, that is cos a equal to cos 60 plus b. Now that is cos 60 cos b minus sine 60 sine b. Now cos 60 is half into cos b minus sine 3 by 2 sine b. Now since we have to get everything in terms of cos, we take the cos together and we take sine together, and on squaring both sides, So here cos square a plus 1 by 4 cos square b minus cos a cos b equal to 3 by 4 sine square b. Now this gives us cos square a plus 1 by 4 cos square b minus cos a cos b equal. Since we want to get everything in terms of cos square, we can write sine square b as 1 minus cos square. Now we take all the terms that is related to cos square on one side. So it is minus 3 by 4 cos square b. When it's taken on the left hand side, we'll get here cos square b minus cos a cos b equal to 3 by 4. So this is how we can even prove the other format also. It is given k equal to sine square 46 degree plus sine square 14 degree plus sine 46 degree into sine 14. And here we have to find least integer of k or ceiling of k. So this is very simple sum, because if we just solve this given expression, we say that k equal to sine square 46 plus sine square 14 plus sine 46 degree into sine 14 degree. Now here we can think this as A, this as B, this is A, this is B. So just if we can correlate here, that sine square A plus sine square B plus sine A sine B, where A plus B equals to 60 degree. So automatically the value of the expression will be 3 by 2. Now here we are trying to find ceiling of k, which will be equal. And next we take the topic, that is we have sine theta sine 60 minus theta into sine 60 plus theta equal to 1 by 4 sine 3 theta. Very simple expression which you have to keep in mind. Now, based on this, we take the next sum. That is, we have sine 20 degree, sine 40 degree, sine 60 degree, and sine 80 degree. We know that sine 60 have a standard value, so we keep that aside. Root 3 by 2. Here we have sine 20 degree, sine 40 degree, that is 60 degree minus 20 degree, sine 80 degree, sine 20 degree plus 20 degree. We have here, we can express this whole expression, sine 20, sine 40 is 60 minus 20, sine 80 is 60 plus 20. So this is in accordance with the above expression. Here we can just think that these are theta, this is theta, this is also theta. So this will give us root 3 by 2 into 1 by 4 sine 3 into 20. So sine 60 is root 3 by 2. So this will be 3 by 60. Obviously, we can understand the derivation of this formula also, which is also a very simple thing. Sine theta, sine 60 minus theta, sine 60 plus theta. We can rewrite this as sine theta sine 60 plus theta into sine 60 minus theta. Just we have written it in this form so that we can say this is sine A plus B to sine A minus B. Now, sine A plus B into sine A minus B, that is sine square A minus sine square B. And this gives us sine theta into 3 by 4 minus sine square theta. Here we can write 1 by 4 outside. It is 3 sine theta minus 4 sine cube theta. 3 sine theta minus 4 sine cube theta, which is the formula for sine 3 theta. and we get the required expression. First of all, we have cos theta into cos 60 minus theta into cos 60 plus theta. Now here we can just simplify this one and we can write cos theta into cos 60 plus theta into cos 60 minus theta. Now here we have a plus b into a minus b. Now this we can write cos theta into cos a plus b into cos a minus b, that is cos square b minus sine square a. So this is giving us cos theta into cos square theta minus 3 by 4. So 1 by 4 outside, and this gives us 4 cos cube theta minus 3 cos theta. So 1 by 4 cos 3 theta. So we can understand that this result is exactly similar to the result which we have got for sine. Just here we have, in place of sine, here we have cos. Else the whole expression is exactly same. It is given that k equal to cos 19 degree, cos 41 degree, and cos 79 degree. And we have to find box of k plus fractional part of k plus seeding of k. So here this denotes GIA as a Crescential function. This denotes fractional part of x, fractional part of x, and lastly, this represents ceiling of x or least integer function of x. So we have to find this expression. So what we'll do at first, we'll simplify the given expression. So we have k equal cos 19 degree, cos 69 minus 19 degree, that is we are representing 41 as 16 minus 19 degree, and 79 degree we are representing as 60 plus 19 degree. So here what we have, if we just compare this with theta, that if we take 19 as theta, so this is 60 minus theta, this is 60 plus theta. So here we can write the ultimate expression will be 1 by 4 cos 3 theta. Now cos 3 theta, that is 3 into 90. Now we know that cos 3 into 19 degree will be definitely less than 1 and greater than 0. So we can say here that 0 less than 1 by cos 3 into 19 degree and less than 1 by 4. Now after this we can say that this is the value of k. So k is lying here, we can easily say that k is less than 1 by 4 greater than 0. Now box of k plus fractional part of k plus ceiling of k. Now box of k, that will give us 0, fractional part of k will be k only, and ceiling of k will be 1. Ceiling of k is 1. So that gives us k plus 1 as a result. Given k equal to cos 70 2 by 3 degree, cos 42 1 by 3 degree, cos 77 2 by 3 degree. So this is given as k, and we have to find here box of k plus fraction part of k plus seeding of k. So here we can express the given expression as k cos 17 2 by 3 degree into cos 60 minus 17 2 by 3 degree into cos 60 degree plus 17 2 by 3 degree. Now, if we correlate the given expression with cos theta into cos 60 minus theta into cos 60 plus theta, then we can write this one as 1 by 4 cos 3 theta. So this will be 1 by 4 cos 3 into 17 by 3. Now this gives us 1 by 4 cos 53. Now we know that cos 53 degree is approximately equal to, so this gives us 3 by 20. So approximately the value of k is 3 by 20. Now from this we can say the required expression is box of t, so box of 3 by 20 plus fractional part of 3 by 20 plus ceiling of 3 by 20. So box of 3 by 20 is 0. Here the result is 3 by 20 plus 1. So ultimately this is 3 by 20 plus 1, which is 23 by 20. We take another form where we have tan theta into tan 60 minus theta into tan 60 plus theta is also a standard form. Here we have tan theta into tan 60 minus theta into tan 60 plus theta. Now here tan theta into tan 60 minus tan A minus B. So that is tan A minus tan by 1 plus tan A into tan 60 plus tan theta by 1 minus tan 60 tan theta. Now here tan theta into root 3 minus tan theta by 1 plus root 3 tan theta into root 3 plus tan theta by 1 minus root 3 tan theta. Now here tan theta into a minus b to a plus b, which is 3 minus tan square theta by 1 minus 3 tan square theta. Now here 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, and that gives us tan 3 theta. So a very simple expression, but a standard expression which you have to keep in mind. And if we have this format, we can say the result is tan 3 theta. It is given k equal to 10, 12, and 1 by 3 degree into 10, 47, 2 by 3 degree into 10, 72, and 1 by 3 degree. And here we have to find box of k plus fractional part of k plus seeding of k. So here given that k equal tan 12, 1 by 3 degree, we can write next one as we can write tan 60 degree minus 12, 1 by 3 degree, which will give us 47, 2 by 3 degree, and tan 60 degree plus 12, 1 by 3 degree. Now here we can correlate this, that is theta, this is also theta, this is also theta. So we have this in the form tan theta tan 60 minus theta into tan 60 plus theta. Now, according to the shortcut, we can say that this result will be tan 3 theta. Now, if we apply here tan 3 theta, we get tan 37, which is approximately 3 by 4. Now, we take the required expression. We have, according to the required expression, box of k, so box of 3 by 4 plus fractional part of 3 by 4 plus ceiling of 3 by 4. Box of 3 by 4 is 0. Fractional part of 3 by 4 is 3 by 4. And ceiling of 3 by 4 is 1. That gives us 7 by 4. We take the next form where it is cos theta, cos 2 theta, cos 2 square theta. We take till cos 2 to the power of n minus 1 theta. This gives us sine 2 to the power of n theta by 2 to the power of n sine theta. Now, this is a standard form which will help us to reduce many complicated calculation. We take one sum which will help us to understand. We have to find the value of k, and k is given in the expression as that is, we have here k cos a, cos 2a, cos 4. And this is given that this is equal to sine 8a by sine a. So we can write that we have, just will try to correlate the given expression and the standard form which we know. So it is cos a, cos 2a, cos 2 square a. Now this will give us sine 2 cube a by 2 to the power of n, that is 2 to the power of 3 sine. Here why 3? Because we have here number of terms 3, or we can say that if we correlate with these two, n minus 1 equal to, so n equal to 3. Now from this we can just rearrange this and write 8 cos a cos 2 cos 2 square a equal to sine 2 cube a by sine. Now from this what we can say that k equal to 8. Just if we correlate, we can say k equals to shortcut of for the series of cos is cos pi by 2n plus 1 cos of 2 pi by 2n plus 1 cos 3 pi by 2n plus 1. Last we have cos n pi by 2n plus 1. This will give us 1 by 2 to the power of n. Now to understand this shortcut, we take the sum, that is cos pi by 15 into cos 2 pi by 15 cos 3 pi by 15 and so on till cos 7 pi by 15. Now here this can be written as cos pi by 15 into cos 2 pi by 15 cos 3 pi by 15 as in accordance with the above format, and will be moving till cos 7 pi by 15 by cos 7 pi by 2 into 7 plus 1, that is 2n plus 1. And here according to the shortcut we can write 2 to the power of 7. So we can get the result very quickly if we have this shortcut in our mind.
Now we understand the logic behind this.
Cos pi by 15 cos 2 pi by 15 cos 3 pi by 15 cos 4 pi by 15 cos 5 pi by 15 cos 6 pi by 15 cos 7 pi by 15. Now first of all we will try to take in the format of sound. We will try to take in the sound form. So in that respect, we can write here cos pi by 15. Next, we look for cos 2 pi by 15, which we have. Next, we look for cos 4 pi by 15, which also we have. Next, we look for cos 8 pi by 15, which it seems that we don't have, but we can express 7 pi by 15, and we can bring 8 pi by 15. So you can see that we can form a pattern with this. Now we are left with cos 3 pi by 15. We are left with cos 6 pi by 15. And we are left with cos 5 pi by 15. 5 by 15 we have taken separately because 5 by 15 means pi by 3. So this will give us standard value. So that has been written separately. Now here pi minus theta, cos pi minus theta is minus cos theta. So you can write here minus, and then we can write cos pi by 15, cos 2 pi by 15, cos 4 pi by 15 into cos 8 pi by 15 into, now cos 3 pi by 15 is also having a standard result, that is basically 3 pi by 15 means here. If we simplify this one, it is pi by 5, that is cos 18. Now cos 18 has the value root 5 plus 1 by 4, whereas 6 pi by 15 has the value root 5 minus 1 by 4. Now this is of the format that cos a, cos 2a, cos 2 square a, cos 2 cube a. So here we can just apply the formula and we can reduce this and we can write 2 to the power of 4 sine 2 to the power of 4 pi by 15 whole by sine pi by 15 into this one we can say a plus b to a minus b. So that is 5 minus 1 by 4 into 1 by 4. Now we can understand here that this is 4 by 4 cancel out and we're left with 1 by 4. And here we have 2 to the power of 4. So 2 to the power of 4 into 2 squares, so that is 2 to the power of 6 we are getting. So 1 by 2 to the power of 6, because here what we had 2 to the power of 4. Here what we had, it is 5 minus 1 into 5 plus 1. So 5 minus 1 ultimately, which is 4, 4 by 4. So that could cancel out and we are left with 1 by 4. 1 by 4 means 2 square and to do a 4 into 2 square to do a 6. Now this one we can simplify further and we can write it is 16 pi by 15, 16 pi by 15, which can be written as pi plus pi by 15 by sine pi by 15. Now this will give us minus sine pi by 15. So this will get cancelled out. There will be a minus sign outside. And this gives us 1 by 2 to the power of 6. But still we have not taken cos pi by 15 value, which is half. So that half now we can utilize half into half into half into half. And ultimately this gives us 1 by 2 to the power of 7. We have utilized this result. We have utilized this result at the beginning. Is a standard value which you have told at the beginning only. That is a standard result we know half. That we will take later on. This gave us root 5 plus 1 by 4. This gave us root 5 minus 1 by 4. Here into half. So we have simplified and we got the result. We take a very nice shortcut here. That is root over of 2 plus under root of 2 plus under root of 2 plus. Now here we take this up to n term. That is here we have n square roots. That is what we say here. That if we have here n square roots and this will give us 2 cos pi by 2 to the power of n plus 1. So this is a very nice shortcut which you have to keep in mind. Just we take one application. Here we have to express actually this value in terms of cos pi by 16. So here we can see that there are 3 square. Here we can understand that here in the given numerical we have 3 square roots. So according to our expression, you can say it will be cos pi by 2 to the power of n plus 1, so 3 plus 1. So this gives us 2 cos pi by 16. Let us understand what is the basic logic behind this sum. If we have cos pi by 4, we know this is 1 by root 5. Now here we can simplify it further by multiplying by a 2. And we can write 2 cos pi by 4 equal to root 2. Now here we can say 2 into 2 cos square pi by 8 minus 1 equal to root 2. This gives us 2 cos pi by 8 whole square equal to 2 plus root 2. Now we know that this is an acute angle. So automatically there is no chance of getting any negative value. So this will be under root of 2 plus root 2. Now again we can write cos pi by 8 as 2 cos square pi by 16 minus 1 equal to under root of 2 plus root. Again we can simplify 2 cos pi by 16 whole square equal to 2 plus under root of 2 plus root. Now since this is an acute angle again, we can write here 2 cos pi by 16 equal to under root of 2 plus root 2 plus root 2. So here we can understand that the result which we have got by application of the shortcut, we can get this by a normal procedure also, just by applying the submultiple angle formula again. Next we take another time. In this type, we have problems which are based on finding the sum of series of sines or cosines whose angles are in a or arithmetic progression. So here the format is the first one which we deal with sine alpha plus beta sine alpha plus 2 beta plus sine alpha plus n minus 1 into beta. This will be sine n beta by 2 by sine beta by 2 into sine of first angle plus last angle by 2. And sine of first angle plus last angle by 2 will give us n minus 1 beta by 2. Now, here this format is actually sine n into difference between the angle by 2 whole divided by sine of difference by 2 into sine of first angle plus last angle by 2. So this is the actual logic behind this formula. We come to the next standard formula. Cos alpha plus cos alpha plus beta plus cos alpha plus 2 beta, and it goes on up to cos of alpha plus n minus 1 beta. Now this will give us sine n beta by 2 by sine beta by 2 into cos of first angle plus last angle by 2. That is, we can rewrite this as sine of n difference by 2 whole divided by sine of difference by into cos of first angle plus last angle whole by 2. So these are two very important formulas which you have to keep in mind, because whenever the sum is given based on this format, you can just apply the formula and you can get the result very easy. Let us take the next sum. We have to find the value of cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 pi by 7. So first of all, the main observation here is that angles are in it because they have a common difference here, which is 2 pi by 7 between the angles. So here we can apply, but before that we can just write what is the difference. Here difference between the angles. Difference between the angles, which is 4 pi by 7 minus 2 pi by 7, which is 2 pi by 7. Now here we can apply sine n difference. N is the number of terms here. So here we have 3. So 3 into difference by 2. So difference is 2 pi by 7 by 2. Whole divided by sine difference by 2. So 2 pi by 7 into half into cos of the first angle, that is 2 pi by 7 plus last angle by 2. Now from here we can simplify this. We can understand that here what we are getting. We are getting equals getting cancelled out sine 3 pi by 7, and this gives us cos 4 pi by 7 divided by sine pi by 7. So the whole expression reduces to sine 3 pi by 7 here cos 4 pi by 7 divided by sine pi by 7. Now this we can simplify as cos pi by 2 minus 3 pi by 7, and here we can write sine pi by 2 minus 4 pi by 7 whole divided by sine pi by 7. Now here if we simplify, then we get it's cos pi by 14 into sine minus pi by 14 divided by, we can simplify this one as 2 sine pi by 14 into cos pi by 14 ultimately minus sine. Method 2. This is the ordinary method. What we do, the given expression is cos 2 pi by 7 plus sine plus cos 4 pi by 7 plus cos 6 pi by 7. And now here, for solving this two of sum, we divide and multiply by sine difference between the angle by 2. So it is sine 2 sine pi by 7. We multiply the numerator also. So it is 2 sine pi by 7 cos 2 pi by 7 plus 2 sine pi by 7 into cos 4 pi by 7 plus 2 sine pi by 7 into cos 6 pi by 7. Now we can simplify here and we can write 2 sine pi by 7. Now this is 2 causes sine B. 2 causes sine B is sine A plus B minus sine A minus B plus sine A plus B minus sine A minus B plus sine A plus B minus sine A minus B. Now we observe that this term is cancelled out. This one is cancelled out, and we are left with only two terms. One is sine pi, one is sine pi is 0. Basically, we don't have this term also is getting vanished out. We are left with only minus sine pi by 7 cancel out, and we get here answer as minus 7. So if we have this concept clear in our mind that how to proceed here, we have to multiply numerator by 2 sine difference between the angle by 2. So when we apply this concept, we can get a very simple format and we are done. We come to next sum where we have to find the value of the series sine theta plus sine 3 theta plus sine 5 theta and so on till sine 99 theta. Now here we can see that is also an AP series. Angles are in AP. Difference between the angle is 2 theta. So here we can straight away apply the formula. But for applying the formula, one thing you have to keep in mind that what is the standard, which term is standard theta. We can understand here that these are all in odd number. So this is 2 into 50 minus 1 into theta. So definitely we have 50 terms. So you can say here sine n theta. So it is 15 into difference between the angle by 2 whole divided by sine difference between the angle by 2 into sine first angle plus last angle by 2. So here just we have to keep one thing in mind that how you have got the number of term only 99 theta that has been represented as 2 into 50 minus 1 into theta. Now here we can simplify this further and we can say here it is sine 50 theta. It is sine 50 theta whole divided by sine theta into sine 50 theta. So this gives us sine square 50 theta by sine theta. Next we come to the another type of sums where we have to use the concept of quadratic equation to solve the sum. It is given in a triangle ABC. We have angle A equal to pi by 4. And we have to find all possible values of tan B, the product of tan B and tan C. So first of all, angle A is given pi by 4 and we have to find all possible values of tan B and C. Basically, we have to find the range of the product tan B into tan C. So in this case, since we have to find the product of tan B tan C, what we'll do? We have the angle A as pi by 4. Now, if we have the angle A as pi by 4, we can say that B plus C equal to 3 pi by 4. We have to find here the product tan B tan C. So we can start it in this so that let tan B into tan C be equal to x. So we have to find the values of x. Now here we can say that x equal to tan B. Now tan C we can write as 3 pi by 4 minus b. So we have reduced these in terms of only one angle. Now here we have tan B in tan A minus B, that is tan A minus tan B by 1 plus tan A tan. Now if we simplify this, we get tan B into minus 1 minus 10 by 1 minus 10 because tan 3 by 4 is minus 1. From this one, we can simplify and we can write minus 10b minus 10 square b whole divided by 1 minus 10. Now we can simplify this. We can write x minus x10 equal to minus 10 minus 10 square. We simplify this further. It's 10 square b plus 1 minus x into 10b plus x equal to 0. So here we get a quadratic in terms of, we get a quadratic in 10. So since it is a quadratic, it is a quadratic in 10b, which is real. Therefore, discriminant will be definitely greater than equal to 0 of the above quadratic. So b square minus 4ac greater than equal to 0. So x square minus 6x plus 1 greater than equal to 0. We can write this one x minus 3 whole square minus 2 root 2 whole square greater than equal to 0, because we can write this one as x square minus 2ab. So 2 into 3 into x, that is 6x. To make it a whole square, we need a 9. We had 1, so we have to subtract 8. 8 means 2 root 2 whole square. 4 to the 8. Now we can apply here a square minus b square. X minus 3 minus 2 root 2 into x minus 3 plus 2 greater than equal to 0. We take a number line. Minus infinity to infinity. 3 minus 2 root 2. Here 3 plus 2. Plus, that is the highest critical point for 4 changes. We need greater than equal to 0. So x belongs to minus infinity to 3 minus 2 root 2 union 3 plus 2 root 2 comma in. The next sum will help us to understand the application of AMG. It is given that theta belongs to 0 comma pi by 2. Now by seeing a sum, how to understand that? Here we have to apply AMG. First of all, a theta is an acute angle. So once we understand that theta is an acute angle, that's the first clue. Second clue, we have to find the minimum value. We have to find the minimum value of minimum value of 2 cos theta plus 1 by sin theta plus root 2 tan. So this is what we have to find the minimum value of this expression. Now all of them are positive values. Why? Because theta is an acute angle. Once we know they are positive quantities, so we can apply AM equal to GM. So we can say that 2 cos theta plus 1 by sin theta plus root 2 tan theta whole by 3 greater than equal to 2 cos theta into 1 by sin theta into root 2 tan theta whole to the power of 1 by 3. Now here 2 cos theta plus 1 by sin theta plus root 2 tan theta greater than equal to 3 into, here we have 2 to the power of 3 by 2 to the power of 1 by 3. So here we can easily understand that this will give us ultimately 3 root 2. So the minimum value of the whole expression is 3 root 2. So you can say therefore minimum value of 2 cos theta plus 1 by sin theta plus root 2 tan theta is 3 root 2. Very simple and very nice application of AMG manipulator. It is given in an acute angle triangle ABC. We have to find the minimum value of tan A plus tan B plus tan C. It is given we have to find the minimum value of tan A, tan B, tan C, and if the minimum value is K, when mean value is K, we have to find box. So this is the whole requirement. Now we know that when we have a triangle ABC, that is A plus B plus C equal to pi, then we have tan A plus tan B plus tan C is equal to tan A, tan B, tan C. Now this we take as x let. Now after that we can apply A and G. Why? Acute angle triangle. That means angles are acute. That is here we can see that here A comma B comma C belongs to 0 comma pi by 2, and therefore we apply here m greater than equal to gm. So tan A plus tan B plus tan C whole by 3 greater than equal to tan A, tan B, tan C to the power of 1 by 3. Now we know this is x, this is also x. So you can substitute here the value x by 3 greater than equal to x to the power of 1 by 3. So x to the power of 2 by 3 greater than equal to 3.
This implies x to the power of 2 by 3 greater than equal to 3, which implies that x is greater than equal to 3 root 3. So according to question, we can write that k equal to 3 root 3. Hence, box of k, that is a gradient function of k, will be 5, because this 3 root 3 lies between 6 and 5, because it is 3 into 1.732, which will be definitely less than 6 and it will be greater than 5.
We come to another very nice technique of finding tan 7 degree 30 minutes. That is, we can see here that this is same as tan 7.5. Instead of applying any submultiple angle or multiple angle formula, we can write here, just we split up this and we write it in this format. Now we multiply numerator denominator by 2 cos 37 and half. Why 37 and half degree? Because this is such an angle which when multiplied with numerator denominator, it will help us by giving either the sum of the angle or the difference of the angle. Like in this case, 2 cos sine b, it is sine A plus B minus sine A minus B whole divided by 2 cos A cos B, that is cos of A plus B plus cos of A minus B. Now this gives us 1 by root 2 minus 1 by 2 divided by 1 by root 2 plus root 3 by 2. Now this will give us root 2 minus 1 by root 2 plus root 3. Now here we multiply numerator denominator by root 3 minus root 2 by 1 because 3 minus 2 is 1. On simplification of this one gives us root 6 minus root 3 minus 2 plus root. So here this technique of multiplying by 2 cos 37 and half help us to reduce the sum in a very least number of steps. That is, it is reduced in a very simple number of steps. We take cos 7 degree, 7 and half degree. We have to find the value of cos 7 and half degree. Now here we can first of all split up cos 7 and half by sine 7 and half. Now we multiply numerator by cos 37 and half. Why? Because when 37 and half is added to 7 and half or separated from when 7 and half is separated from 37 and half gives us a standard result. Now this gives us cos A plus B plus cos A minus B whole divided by sine 45 minus sine 30. Take 1 by root 2 plus root 3 by whole divided by 1 by root 2 minus sine. This gives us root 2 plus root 3 by root 2 minus 1. Now we multiply by root 2 plus 1. So we get root 3 plus root 2 by 1. This gives us root 6 plus 2 plus root 3 plus root 2. And we're done.